So in chapter 9, we started talking about capital budgeting. Okay? And again, capital budgeting is regarding the capital investment, how to decide which investment to choose, right? And so on. Right? So in chapter 9, we pretty much spent all the time talking about how to calculate NCF, right? Net cash flow, right? Net cash flow. So that's the first step. We have to, in order to evaluate which project to choose, you have to calculate the cash flows you can expect from that project. Okay. Now in chapter 10, we're going to actually talk about some different ways, different methods to actually evaluate and choose, okay, among the alternatives. Okay. So the first one is a net present value, NPV approach. Okay. And I'm pretty sure most of you have pretty good ideas about NPV. I've talked about this already in the last week. Yeah? But let's just, talk about some more details. Okay? So net present value is the, as you see here, the present value of stream of future cash flows minus net investment. Net investment is initial investment, the amount of money you need to invest in the beginning. Okay? And we're thinking about the net cash flow in the future, assuming when we say capital, we mean it lasts more than a year, right? So we're talking about multiple year, 1, 2, and we expect some amounts of net cash flow. Okay, so we first have to discount all these future cash streams, okay, to convert them into present value, okay, present value of a net cash flow, okay, and add them up. Okay, so that's what we are doing here. We discount net cash flows using some discount rate K, okay, and add them up, right? And then subtract NI and B from that. That's the net present value. Okay? Well, let me show you how to use calculator to come up with these values easily. Okay? Let's see. I think Unji showed us how to do that last week, right? Yeah. But just in case you didn't get it, let me show you once again. So when you have this calculator pulled up, always make sure that you clear the register, right? So just press the orange key and finance orange key register. So these two keys will clear all the memories in the calculator, right? All right, so, okay. So first problem, for example, here, net investment is $50,000, and you expect the same amount of net cash flow for the rest, all 6 years. Okay, so this is a 6-year project, but you happen to expect the same amount, what, $12,500? For all 6 years, right? Well, in that case, it's an annuity, right? It's equal payment, repeating, right, over the life of the project. So calculation becomes very simple, right? All you need to do is, right? So here, if you look at the calculator, look at the blue keys here. Here's CF0, CFJ, and NJ. Right? And what you need to do is CF0 is cash flow right now in the beginning, right? And cash flow in the beginning is only what? The initial investment, net investment of $50,000, right? So you need to enter that, right? So 50,000, it's a little slow, right? And this is cash outflow instead of cash inflow. So you need to make it a negative number. Change sign, CHS here. Make it negative 50,000. And then enter blue key and CF0, okay? Notice that 50,000 becomes 50,000.00, right? So calculator is letting you know that it received, it accepted your entry, right? So it is now in the memory, right? And then all you need to do is enter the rest of the cash flows, okay? But again, we have the same repeating cash flow. So 12,500, okay, and just blue key CFJ, okay? That's the first cash flow, CF1, right? But now we have repeating the same number 6 times, okay? So all you need to do is enter 6 and G, blue key, and NJ. So you just told the calculator that the same number, 12,000, repeats 6 times, okay? And then you need to enter the interest rate. According to the textbook, the interest rate is 14%, right? If you go back to, oops, what was it? Yeah, here. The textbook calculation is here. K is 14%, right? So just enter 14. Make sure you enter 14 instead of 0.14, right? 14%. And the I stands for interest rate, okay? And then you're ready. So just use the NPV key, that's the orange key, right? So click yellow button and NPV. That's it, right? So net present value is negative $1,391.66, okay? On the textbook, it says $1,387. There's a little bit of difference, okay? I think that's because textbook used table, okay? PBIFA table, right? Instead of calculator. Which one should you trust? Calculator, because table is wrong, right? Table it shows only third digit up to the third digit below the decimal point, okay? So, I mean, here it's a minor difference, but if you're dealing with large amount of money, that difference will make a huge difference, okay? All right? All right, so the second case is slightly more involved because we have different cash flows, okay? But the only difference is now you have to enter each number, right? So press 5,000 and, okay, so let's clear the memory again. Actually, you don't have to clear the finance function because we're going to use the same interest rate, right? Somebody asked about the calculator at the end of last class, okay? All financial calculators will have these 5 keys: N, I, present value, payment, future value, right? So if you see these 5 keys, then that's a financial calculator. Otherwise, it's not, right? So, you know, I don't care which financial calculator you use, but, you know, you have to know how to use your own calculator, okay? Okay, all right, so here we go. So first, what was the first number? 5,000, 10, 15, 15, 25, 30, right? 5,000, 10, 15, 15, 25, 30, right? All right, so initial investment was 50,000, change sign, and put it as CF0, right? And then 5,000 as CF1, 10,000 CF2, just keep pressing CFJ, right? And what was it, 15,000? Okay. Here, I think 15,000 repeats twice, so you can use NJ, or you can use, you can press 15,000 again, right? And CFJ. Let me just do 2. Okay. And then what? Next one is what? 20,000? 25, 30. Okay. So 25,000. Okay. And 30,000. Okay. And 14% as interest rate. And then press NPV. 7,738, right? Here, textbook calculation is 7,735. Again, the slight difference between the table version and the calculator version, okay? So you can use calculator to come up with the net present value easily, right? Okay? If you have your textbook, why don't you open page chapter 5, question number 6. Since some of you are new to this calculator, let me show you how to solve a typical financial problem, okay, using this calculator. That's question number 6 on page 180, chapter 5. All right. Let me read the problem for you. Your great uncle Claude is 82 years old. Over the years, he has accumulated savings of $80,000. He estimates that he will live another 10 years at the most, and wants to spend his saving by then. Okay. Uncle Claude places his $80,000 into an account earning 10% annually and sets it up in such a way that he will be making 10 equal annual withdrawals. The first one occurring 1 year from now, such that his account balance will be zero at the end of 10 years. How much will he be able to withdraw each year? Okay? So I always recommend you to illustrate the problem using timeline. Okay? All right. So he is currently 82 years old, okay? And he expects to live another 10 years, 92. Okay? And the thing is, he currently has $80,000 saved, okay? And he's going to put that money into an account, okay? So here's the initial investment of $80,000. So N is 10, and I is 10, right? Says the account earns 10% annually, okay? And his plan is every year, starting from 1 year from now, he's going to withdraw certain amount of money, equal amount of money, right? 10 times, okay? So that at the end of 10 years, his total balance will be zero. Oh. he's going to withdraw the last time, okay? But when that happens, it's going to be 0. Balance will be 0, right? So the question is, how much should this withdrawal be? Okay? That's the setup, right? So if you want to solve this using table, you have to use what? You have to do some manipulation using the annuity concept, right? So should we use a present value or future value of annuity? I think you should use present value of annuity. Yeah, present value of annuity is 80,000. Okay, future value is 0, and you should somehow come up with the payment. Okay, but if you use the calculator, you can solve it very easily, right? Just clear again once again. Okay. Want to try, Juan? Just tell me what to do.
First you type 80,000.
80,000.
And present value.
You have to change the sign, make it negative because it's a initial investment. That's a cash outflow, right? So, and make it what? Present value. Present value, okay? Did you just notice 2 zeros here? So the calculator just received that amount, okay, as a present value, and
you press 0.
okay,
And future.
yeah, future value is 0. That's good, all right.
Put 10.
Okay,
And interest.
as the interest rate,
And 10.
and also number of periods. Oh, okay, forget about it. Clear. Okay, 10 as number of, yeah. I got a little bit lazy there. Right? I hope it's okay, right? What else?
And you press P.
Right. And then you ask payment, right? Payment key is right here, right? Yeah. So $13,019.63, right? So every year, your uncle can withdraw $13,019.63, right? And if you do that for 10 times, your total balance would be 0. Okay? So, you know, it's very convenient. Yeah? Most of the problems, you can solve this without financial calculator, right? Either using the table or using the formula, okay? But there is IRR problem, internal rate of return problem, okay? And I'm going to mention it sometime today, okay? You cannot solve this problem without financial calculator, okay? So you have to have financial calculator. Well, if you can probably solve it, but it'll take at least a few days because it requires iterative step, right? Well, it takes a long time, okay? So I really recommend you to have financial calculator or download app on your smartphone, okay? Okay. So that's the idea of net present value, and that's how you calculate the net present value. And then how do you use, once you calculate the net present value, how do you use it to make the decision? Okay? If you're dealing with independent projects, when you have multiple alternatives, and suppose they are all independent, right? Then you can choose all the projects that has positive net present value, greater than or equal to 0. Okay? So if you have projects A, B, C, D, E, okay? and net present value comes out to be, say, 7,000, 2,000, negative 2,000, 10,000, negative 1.5 thousand, okay? Net present value. Okay? Then as a profit maximizing investor or shareholder wealth maximizing financial manager, okay, you should choose all the projects that return positive net present value, right? You should not leave anything out, okay? Because then you are losing the opportunity to make positive return, right? That's the case of independent projects. But if you're dealing with the mutually exclusive projects, okay, then you have to rank order these. First of all, negative return are out of question, right? If you have negative net present value, then there's no reason to consider those. Okay? But out of these three projects that return positive net present value, right? You have to start choosing with the largest net present value. What? Up to what? Should you choose just the largest one? That's it? Oh, okay. Yeah, I guess I'm confusing you, right? So let's say A, B, D, or mutually exclusive, which means like choosing a location, right? You're trying to build a new plant or whatever, right? And A, B, D are or A, B, C, D, E, or different location. So if you build here, then that means A and B are not attainable, or it's possible, right? Yeah, in that case, you should choose the largest net present value option. Okay? I was thinking more of the rationing, capital rationing, right? If you have certain limit, okay, or limited fund or finite fund, okay, then you should choose the one until your fund lasts. Okay, as long as you have sufficient amount of money to invest, right? It could be D and A, right? Or if you don't have enough money to afford D and A, then you should just choose the largest net present value option. Okay. All right. Sources of positive net present value project. It's a little bit seems a little bit out of the scope of this chapter, but I guess it is a useful thing to consider. The textbook, the chapter, is trying to give you some understanding of how this net present value, positive net present value projects can come around. Well, I'll have to bring some microeconomic discussion here. If the market was perfectly competitive, you remember the perfect competition in microeconomics, right? If the market was perfectly competitive, then the equilibrium would be achieved at this point, right? This is price, quantity, marginal revenue equals demand curve, right? And this is marginal cost, average total cost, okay? And if you remember, there were some conditions for perfect competition, right? You remember those conditions to achieve the perfect competition? What are the conditions? In Korean, if you like. I'm sorry? Homogeneous product. Very good, right? Homogeneous product. Okay. Homogeneity. Which means all the producers produce identical product so that consumers have no way of identifying whose product this is, right? And that means there is no reason to advertise, okay? Because consumers have no idea whose product it's yours anyway, right? Anyway. And that also means infinite number of producers, okay? And then free entry, free exit, the kind of condition, right? But when these two conditions are satisfied, right, you will have this horizontal demand curve. Okay? Horizontal demand curve means every producer accepts the same price. Okay? And if you try to charge 1 cent higher than market price, what happens? What? No one will buy your product, right? In other words, your demand disappears, right? There is no demand above this horizontal line. Okay? What about if you want to charge 1 cent less than the market price? Huh? Right, which means you can sell all you want, right? If you charge 1 cent less than market price. But the thing is, you don't need to do that. Why? I can't hear you. Okay?
I lose 1 cent by one product every time I sell it. So sell it,
Okay.
and I lose it.
Right. So I guess my question is, even if you sacrifice 1 cent, sometimes we do that, right? I mean, in real market, sellers give some discount to sell more, right? And here in this situation, if you lower your price by 1 cent, you can sell all you want. Why don't you do that?
You can still sell at the market price as many as you want.
That's right. Because you can sell all you want or all you can produce at the market price. The assumption is there are infinite number of producers and individual producers are so small. It's 1 out of million, billion producers, right? So you don't have to worry about not selling all you want or all you have, right? So there is no reason to reduce your price. You can set the price at the market price and you can still sell everything, right? Anyway, that's the situation, right? If that's true, then the price is equal to marginal cost and average cost. So what happens to your profit? Your profit is 0 because profit is total revenue minus total cost, right? And total revenue is P times Q. Total cost is ATC, which is per unit cost, right? Times Q, right? And P minus ATC. And as you see here, price is equal to ATC. So this is 0, right? And your profit is 0. So under the perfect competition, everybody makes 0 profit. That's the condition, right? And here, our chapter is trying to, for some reason, trying to emphasize how the positive profit is possible, right? And that requires, of course, non-competitive situation, right? Imperfect competition, right? If these conditions are not satisfied, right, then demand curve will be downward sloping, right? Either we're talking about product differentiation situation, if consumers can somehow identify your product, okay, and develop some attachment to your product, if somehow they like your product over other producers' product, okay? Or there are some barriers into the industry, okay? So you can eliminate or prevent some producers from coming into the industry, right? Then you're going to have this downward sloping demand curve, right? Which means price matters, right? If you charge higher price, quantity demand will be low. If you lower your price, quantity demand will be high, right? And in this situation, okay, typical, yeah, marginal cost, ATC, right? And here will be marginal revenue curve. Marginal revenue curve will be below the demand curve. It will be twice as steep as demand curve, right? I don't have time to explain all that thing, but I hope you remember, right? So the profit maximization occurs right here, where the marginal revenue equals marginal cost, okay? So this will be the profit maximizing quantity, okay? And the price will be determined on the demand curve, right? If you supply these many units, right, then the price will be determined right there, right? But at that time, average total cost is right here, right? So there is the difference between the price and ATC, right? So your profit will be what? P minus ATC times Q, right? That will be positive. Yeah? So in reality, we don't have perfect competition. You know that, right? Perfect competition is just an imaginary situation, right? And we don't have it in reality. In reality, we have what? Imperfect competition all the time, either monopoly, oligopoly, right? So yeah, we can have positive net present value projects. Okay? All right. We're going to talk about some other methods, some other way to come up with the decision, right? It's a little bit out of order, but net present value, to give you the conclusion first, NPV method is the best. It was considered the best criterion, right, to make the decision. The reason is it is theoretically the best criteria, logically, right? Because what we are doing is we think about the future cash flows and discount the future cash flows to the present value and compare that total present value to the total current investment, present value investment, right? So if it's positive, yes, it makes sense to invest in that project, right? Realistic assumption that cash flows are reinvested at the cost of capital. Well, in order to understand this, you have to wait a few minutes, right? After discussing other methods, right? Then you'll be able to understand this, okay? And it also considers the time value of money, yeah, because some other criterion, right? It does not consider the time value of money, right? Weakness, net present value results are not easily understood. I don't agree with this. I think you all understand net present value concept, right? Well, at least if you want to be a manager in a company, right, then you should understand the concept of net present value. Okay? Yeah, all right. And it does not consider the value of real option. Well, again, we're going to talk about real option at the end of this chapter, right? Real option is, instead of comparing a few alternatives, sometimes we may have to consider some other possibilities like completely abandoning the project or, selling the company or whatever, right? So those are the real options. We'll talk about it, right, as we go on. All right, second method of evaluating the project is profitability index. Okay? Profitability index, as you see here in the formula, it is the ratio of the discounted future cash flows to the net investment. So you can see it's pretty much the same idea as net present value. Net present value was this numerator minus denominator, right? Profitability index, PI, is simply the ratio, right? So you can see the consistency between the net present value and profitability. If the net present value was positive, what do you expect about the PI? It will be larger than 1. Why? Right? Because net present value was this one minus this one, right? So if that's positive, that means this numerator is greater than the denominator, right? So PI will be greater than 1. If net present value was negative, obviously, right, then the numerator was smaller than the denominator, right? So that will give PI less than 1. Okay? So it's very consistent idea, right? The only difference here is some interpretation. Okay? Profitability index gives this interpretation. It's the present value return for each dollar of initial investment, right? So, for example, after the calculation, suppose you got 1.15 here, right? Then what that means is your return, the present value of all the cash flow return, was 1.15 times the net investment, right? In other words, for every dollar you invest right now, you're going to get $1.15 in terms of discounted future cash flow, right? So that's the only use of profitability index. Okay? So once you calculate the the profitability index, how do you use to make the decision, right? Well, independent project, accept if the profitability index is greater than or equal to 1. The same thing as net present value, right? Accept the project if the net present value was greater than or equal to 0, right? Why do you accept if it's equal to 0? If net present value was equal to 0, that means you're not gaining anything, right? But 0 is nothing, isn't it?
I mean, the advantage of doing project, there was
okay, learning the experience, gaining the experience. Yeah, okay, well, I'll accept that. Yeah, yeah. Well, you have to consider that the cost we are talking about here is opportunity cost, right? So it includes everything, right? All the costs. So when we come up with the net present value is 0, you might say, why bother, right? I mean, after spending so much time and efforts, right, you gain nothing. So actually not doing is better than doing, right? But you have to understand that actually the cost of your time and efforts are all counted, right, as a cost, as a part of net investment, right? So if its net present value is exactly 0, then you should be perfectly indifferent between doing the project and not doing the project. It doesn't make any difference, right? Because all your time and efforts are already considered, right, as a part of cost, right? Well, maybe you're right. The only reason to do it in that situation is just to gain experience, maybe, right? Yeah. Or maybe in that case, maybe you can always also quantify, monetize the value of experience, right? Value of experience as the benefit, right? Right. All right, mutually exclusive project, again, if you have to choose only one, right, then you should accept the project with the largest profitability index. Okay? All right, here's an interesting thing. Even though the net present value and profitability index are very consistent concept, as I just explained, right, sometimes they can produce conflicting results, right? So here's an example, project J and project K, right? And project J requires $20,000 net investment, and the present value of net cash flow is $25,000, right? So if you calculate the net present value, that's $5,000, right? And if you calculate the profitability index, that's 1.25. That's 25,000 divided by 20,000. Okay? In project K, the discounted future cash flow is 14,000. It requires $10,000 net investment, right? So if you calculate net present value, that's 4,000, right? Which is smaller than 5,000 here, right? So in terms of net present value, if you use net present value criterion, you should choose what? Project J, right? But if you calculate the profitability index, right, it's 1.4, greater than 1.25, right? So if you decide to go on with the profitability index criterion, then project K is better choice. What do you think? Which one should you choose? Yeah. Invest, okay, right? Because initial investment is smaller, right?
You invest 11,000 less, but you win 1,000 less. So.
Well, your net investment is $10,000 lower, right? Yes. And your return is $11,000. Okay, that's what you're saying, right? Okay, right. So his idea is project K, right? Anybody for project J? Yeah.
They are mutually exclusive.
Yes, they are mutually exclusive. Huh?
Capital is not a problem. Then you can get more for the.
Both? Well, if they are mutually exclusive, which one should you choose?
Yeah, I said then I would go for J.
J? What? Why?
Because it does still end up with more money, and there's no guarantee that you can use the 10,000 to go to invest
Okay.
that day
All right.
to get more than 1,000 to be smart.
All right. Thomas, right? Thomas. And here's Jonathan. All right. How many of you with Thomas going for net present value? About 10 people, right? Yeah, about 10. How many go for profitability index or Jonathan? 1, 2, 3, 4, 5, 6. All right. I guess Thomas wins. Yeah. Well, if there is no capital rationing, right, then net present value is the rule, because the ultimate goal, remember, ultimate goal is shareholder wealth maximization, right? So if you go for project J, you will end up adding or increasing shareholder wealth by 5,000, right? Rather than 4,000, right? So that should be the criterion. However, if you are facing capital rationing, in other words, you don't have enough money, or if you have very tight financial situation, so you need higher return on your money right away, right? Remember, PI, Profitability Index, gives you the return on $1 investment, right? Return on $1 investment in that investment, right? So if you really count, when I spend $1 right now, how much return do I get immediately, right? Then Profitability Index is the way you should go. Does it make sense? Because right now, if you invest $1 in project K, you get $1.40 back, right? But project J gives only $1.25, right? Lydia, does it make sense? Okay, yeah. So ultimately, again, that's why we say the net present value is the best criterion. Ultimately, our goal is maximizing shareholder wealth, right? And well, one of the most important jobs or tasks of the financial manager is to come up with the fund, right? So if you have this project like Project J that can increase the shareholder wealth, right, then ideally you should be able to come up with enough fund so that you can take on this Project J, okay? That's the role of financial manager, right? All right, the third criterion, it's called the internal rate of return. Okay? And this is kind of interesting idea. It's a little more, in my opinion, this is more complicated than the net present value concept, right? Okay. If you read the chapter, they did some survey, okay? Survey of the hundreds of managers, right, in the companies, and they ask which method do you use, okay? And you see the NPV and the IRR methods are about the same, right? Equally popular, but NPV is slightly more frequently used. Okay? IRR, internal rate of return, it's the discount rate that makes the net present value equals to 0. Okay? So as you see in the formula here, we are pretty familiar with this term, right? Net cash flow discounted by 1 plus what used to be K, right? So like 14% or whatever, right? If you know the discount rate, then using that discount rate, we could discount all the future cash flows and convert them into present value, right? But here, we don't know that discount rate, right? That's the question. We're trying to find the discount rate which makes this term equal to this term so that this will be 0. That present value will be 0, right? In other words, what interest rate makes the initial investment and the future cash flow, present value of future cash flow, equal to 0? I mean, equal between them, right? So that the net present value is equal to 0, right? Here, if you look at this graph, that will make more sense. Yeah? All right, we have two different projects, Project A and Project B. Okay? And look at this blue line, blue curve here, Project A. Right? And we have net present value on the vertical axis and discount rate on the horizontal axis. Right? And as we know, if the discount rate goes up, then the net present value goes down. Right? Because we are discounting, we're talking about this rate here, discount rate, right? Instead of 5% discount rate, if you use 10% discount rate, right, that's going to reduce this total value, right, value of the present value of the future cash flow, right? So if you subtract initial investment, right, the net present value will be lower, right? Make sure you understand that. Okay? So as you see here, if the discount rate was 0, then that means that this 25,000 is completely undiscounted value, right? Just add up all the future cash flow, and apparently you can borrow money at 0% interest rate, right? Then the future value is equal to the present value, right? But if you have to borrow money at 5% interest rate, then that's going to bring the NPV somewhere to what, 15,000 level, right? And so on. So it goes down this way, right? And then if the discount rate becomes about 13%, right? Then your net present value becomes 0. In other words, your future the present value of your future cash stream and the current investment becomes equal, right? Your net present value is 0, right? Last semester, you should have learned about bond. What do we call that? Yield to maturity. Yield to maturity of a bond. Okay? And bond, sorry, I'm running out of time here. The nature of bond is you invest certain amount of money now, right? And then you receive periodical coupon or interest payments, right? And at the end of the term, you receive the interest payment, but you also receive maturity payment, which is the par value of the bond. Okay? So you could calculate the yield to maturity this way, right? So let's say this is P0, initial price. Suppose you paid certain amount of money for the bond, okay? And you receive periodical interest payment, right? And at the end, you receive the par value. What's the rate of return on that bond, right? So P0, we could use this formula, summation of interest payment discounted 1 plus K KD T, right, plus M divided by 1 plus KD, yeah, the same, yeah, okay, yeah. Here's the summation, okay. So the story is, if you have T years remaining, it should have been 10, sorry, N, sorry, yeah, that's why. T goes 1 from N. Oh, yeah, that makes sense. Yeah. Okay, yeah. So you discount all the future interest payments and make a summation. That's the present value of future cash stream, right? And then there's one-time lump sum payment, right? And you discount it for N years, N period, right? Okay. Well, if you want to calculate the internal rate of return, right? That's the rate of return rate or discount rate, which makes the right-hand side equal to the left-hand side. Okay? So suppose you paid, say, $900 for this bond, right? And suppose you get $50 annual payment, right? 1 plus IRR, okay? Plus, and at the end of the term, you get, say, $1,000 back. 1 plus IRR. Let's say, well, 10 years remaining. Something like that, right? T goes from 1 to 10. Okay? So yield to maturity was solving for this internal rate of return, right? Internal rate of return is the discount rate which equates the left-hand side to the right-hand side. Okay? The same idea, right? Same idea here, right? So we have, you can say, this is the left-hand side and this is the right-hand side, because you can bring it over here, okay? And then you know, you can solve it for IRR. Okay? So again, that's the discount rate which makes the present value of the future cash stream equal to the initial investment. Right? The same idea. Right? All right? How do you do that? Well, if you use the calculator, you can do it easily. Let me show you just today, and then I'm going to let you go today. All right, so clean up the register. All right. And suppose well, why don't we solve this problem? Let's say. Suppose the payment, you paid $900, okay? So $900 as the initial investment, which is the present value, okay? Okay? And payment is $50 annually, let's say. Payment, okay? And what was it? 10 years, okay? 10 years as the number of periods. And what else? What else do I need? Huh? Well, that's what we are looking for, right? What about the par value? Yeah, 1,000 as the future value, okay? And then solve it for interest rate. Yeah, 6.38%, right? That's the internal rate of return. Internal rate of return, right? So if you have a financial calculator, you can solve this problem very quickly, right? But otherwise, it's going to take a lot of time, right, to calculate the internal rate of return, right? Yeah.
Do you use orange key at YTM?
At YTM? No. This is a simple, this is not a net present value calculation. So you just use enter the future value, payment, present value, and number of periods, and solve it for I.
And when do you use IRR on orange key?
Oh, you mean this one, IRR. I forgot. When do you use IRR key? I knew there was a case, right? Well, let me try to remember, right? Yeah, but in this problem, in this simple problem, you don't need to use IRR key. Right? Yeah, I'll tell you next class if I remember. Yeah. All right, so we're going to continue and try to finish this chapter on Thursday. All right? Any questions? All right, see you later.